So today we'll be talking about average and instantaneous rates of change. First, what is a rate of change? So its definition is, it's a measure of how quickly one quantity, the dependent variable, changes with respect to another quantity, the independent variable. There are two types of rates of change that we're going to be studying, mainly the average rate of change, which is IROC, and the instantaneous rate of change, IROC. So the first one here is the average rate of change. So the average rate of change is a change that takes place over an interval. Graphically, it is the slope between 2 points, which is also known as the slope of a secant. So here we have 2 points. We have point P, which is x1 and f at x1, and we have point Q up here, which is x2 and f at x2. If we're finding the slope of the secant, which is the line going through point P and Q, we're really just finding the slope of a line. Okay, so for IROC, it's going to be the change in y over the change in x, also known as rise over run. And in terms of our points, it would be f at x2 minus f at x1, all over x2 minus x1. So we're really just using the exact same slope formula that we used in grade 9, because we're really just finding the slope of a line. The second type of rate of change is instantaneous rate of change. And an instantaneous rate of change, also known as IROC, is a change that takes place in an instant, i.e. at a very specific point in time. Graphically, it is the slope of a tangent at that point. And a tangent line to a curve at point P is really a straight line that most resembles the graph near that point. The tangent line can only touch the curve locally at point P, although it may cross the curve elsewhere. Okay, so here we see at point P, we've drawn a line that approximates the slope at that point. So in drawing this line, there is about equal spacing on either side of where that line hits the point P, which is where the line is tangent to. So here we are in Desmos. I just put in a random curve, and this red line is actually Desmos graphing the tangent line. So what you'll notice is that where the curve is steepest, the tangent line is also steepest. If we move it up, as the curve begins to flatten out, that tangent line is also flattening out. The slope of the tangent line is becoming less steep. And you'll notice that once again, there is about equal spacing above and below. You need to make sure that you're only hitting the curve at that one point. Okay, so it shouldn't be crossing at two different points very close to each other. Okay, but you will see that this red line does extend, and if you extended it far enough, you would eventually hit this blue curve again. Okay, but here we can watch it move, and we can see how the tangent line adjusts. So it's kind of like you're imagining you're moving a pencil along the curve so that it always hits it at one point locally, and you're really just approximating the slope of the curve with a straight line. If you want to learn how to do a tangent line properly, then you actually need calculus to do it. So for us, this really is an approximation, but you should understand roughly what a tangent line is. A tangent line is just a line that approximates the slope of a curve. And if you were to zoom in on this curve over and over and over again, and get closer and closer and closer, eventually you would see that the tangent line and the curve do look pretty similar. Okay, because as we zoom in closer and closer and closer on a curve, it does begin to look more and more like a straight line. So in order to find the slope of this tangent line, we're going to need 2 points, because we only know how to find the slope of a line when we know 2 points on that line. And we're actually going to be estimating the slope of this tangent line. In order to properly find the slope of a tangent, so in other words, in order to properly find instantaneous rate of change, you need calculus. We're going to use a technique to estimate it. So it's going to be reasonably close, but it will not by any means be perfect. So we need 2 points, and what we're actually going to do is we're going to use a method called the centered interval. And now we only know 1 point on this tangent line. We know point P. It also happens to be a point on the curve. We need 2 points. So what I'm going to do is on my blue curve here, I'm going to go up a little bit to x plus 0.001. And then I'm also going to go down a little bit to x minus 0.001. Okay, so I've now taken 2 points, one that's up a little bit, one that's down a little bit. And using those 2 points, I'm going to be able to find the slope of the line that passes through those 2 points. So here I've drawn in black the line that passes through my 2 green points. And you can see that the line that passes through those points is pretty much parallel to the tangent line. So that means that they would have the same slope, or roughly the same slope. Remember, this is an estimation. So by finding the slope between my 2 new green points, i.e. my centered interval, then I can actually approximate the slope of that tangent line. And over here, I've just put the y values that match with the x values. So when we had x minus 0.001, the y value that matched with that would be f at x minus 0.001. And same for x plus 0.001. So now I have my 2 points. And using these 2 points, I can actually calculate the slope. So here is the IROC formula. We've just put it into that delta y over delta x slope formula. On the bottom, because we have x plus something minus x minus that 0.001, it actually just, the x's cancel, and it simplifies to 0.002 on the bottom. Now I've chosen 0.001 to be my so-called little bit, but you could actually use a different value. For us to be consistent, we're always just going to use 0.001, and that way we all get the same answers all the time. But if you wanted to be more exact, you could add 0.000001 and subtract the exact same thing. And that would once again get you a centered interval. But for our case, we are just going to use 0.001. So let's do some examples of these. So here's our first example, and they're asking us to draw tangent lines at point P, Q, and R. So what I would recommend doing is on your piece of paper, taking your pencil and following the curve along with your pencil until you get to the point. And then move your pencil a little bit so there's about equal spacing above and below. So pause the video and try drawing some tangent lines. Okay, so there's my first one. It touches at only 1 point. There is about equal spacing above and below. I could adjust this up a little bit even. And there's my first tangent line. And there are my next two. Once again, only touching each at the 1 point and about equal spacing on either side of the point. Okay. For point R, it's a fairly steep line because the curve is fairly steep there. And for Q, it's a flatter line since the curve is less steep. So for example 2, we have that the water is draining from a large tank. After t minutes, the height of the water in liters remaining in the tank is given by the function h of t. For part A, they want us to determine the average rate of change at which the water empties between 5 and 10 minutes. So, 1, they told us it was average rate of change, but we would have also known that because they're actually giving us the interval of time. Okay, so they're telling us it's between 5 and 10. That means automatically it is average rate of change. So we're going to find IROC. And to do that, we're just going to take the point 5, h at 5, and the point 10, h at 10, and we're going to plug them into the slope formula. So it's going to be h at 10 minus h at 5 all over 10 minus 5. And then to find h at 10, we just go to our function h and we plug 10 in there. And then we're going to subtract h at 5. So we're going to do the exact same thing. We're going to go to our function h, and we're just going to plug the 5 in. And on the bottom, we still have 10 minus 5, which we could also just simplify to 5. And now you're working this out in your calculator. Before doing that, you can simplify it a little bit, right? We have 150,000, and then we're going to be subtracting 150,000. We know those are going to cancel out. But really, you're just typing this in to a calculator, and you will end up with negative 37,425 on top, all over 5, which will simplify to negative 7,485. And then the units here, H is in liters, time is in minutes, and since we did H over T, then we're going to do liters per minute. Now writing out a sentence for this, the water is emptying at a rate of 7,485 liters per minute. You need to make sure that you're always including units when you're dealing with rates of change. And because it was a negative rate, that negative really just meant that the water level was going down. It meant that it was emptying. So by putting the word emptying in our statement, we took care of that negative, so you don't want to still include it. Part B, this time they're asking for the instantaneous rate of change at which the water empties from the tank after 15 minutes. Really, so that means exactly at 15 minutes. So we know this is an instantaneous rate because they told us, but also because they're only giving us that one value. So we need to turn that one value into two values by doing 15 minus our little bit of 0.001 and by doing 15 plus that little bit. So that would end up being 14.999, and this would end up being 15.001. Okay, so for IROC, what we're really going to do is we're going to do H at 15.001 minus H at 14.999, and then that's going to be all over 15.001 minus 14.999. Okay, so take a minute, find those two H values, plug in the numbers, and then see what you get. Okay, so there it is with everything filled in. And if we worked this out, you would get negative 7,470, once again, liters per minute. So therefore, at 15 minutes, the water is emptying at a rate of 7,470 liters per minute. Okay, so here's our next example. Okay, it's the exact same idea, so you might even want to pause the video and give this one a try by yourself. But for example 3, the height of the tide at the seaport t hours after midnight is given by this function h of t. Find the rate of change in the height of the tide between 3 and 9 a.m. Okay, so t hours after midnight, so at 3 a.m. t would equal 3, and at 9 a.m. t would equal 9. Since they're giving us two values and we're finding the rate of change between them, we're really finding average rate of change. So we're just going to do h at 9 minus h at 3 all over 9 minus 3. So take a minute, fill that in, and work it out. Okay, so I have plugged everything in. I'd recommend simplifying this a little bit before you plug it into the calculator, because a lot of people will try and plug it into the calculator wrong. So 1, you have 8.5, then you're subtracting the same 8.5. Those will cancel really easily. And the other thing would be inside this cosine, 9 minus 5 would be 4, so you have 4 pi over 6, which is really 2 pi over 3. So I simplified inside both of the cosines first, and that makes it a much easier statement to put into your calculator. So our answer was negative 0.75 meters per hour. So therefore, the height of the tide is decreasing at a rate of 0.75 meters per hour between 3 a.m. and 9 a.m. Now for our next example, it's saying determine an estimate for the rate of change in the height of the tide at 6 p.m. 6 p.m. is really 18 hours after midnight, so that is our t value. And then remember, for instantaneous, we're going to subtract 0.001 and add 0.001. So that's how we get 17.999 and 18.001. So give this one a try. Okay, so if you plug it in, this is what you would get as your final answer.